Okay, we're up to determining the types of stationary points. Now, we've kind of done a little bit of this already, and this chapter I wouldn't say is that difficult. It's more putting all the pieces together that we've done prior to this. So just to look at this, if we're doing a minimum turning point, that would be like where it bottoms out. Okay, so where it gets to our range, yes, our range, and it bottoms out. So it's the lowest, the minimum value at which it can be. Okay, and our maximum is the highest point it can be. Our horizontal inflection is where it's going to like have a gradient equals 0. So with that, we can have some rules. Okay, so our minimum turning point, our f-x should equal 0. So our gradient equals 0, which is true. And f-x should be greater than 0. Therefore, it should be concavity up, not bell curved. Our maximum turning point is going to have our f dash equals 0. That is our gradient equaling 0, which it does. And it's going to be f dash x is going to be less than 0. That is going to be curved down. Okay, so that makes sense. The horizontal inflection, this is going to equal 0. And this will also equal 0. That's a bit interesting. We'll come back to a little bit later. Now, if we're going to do an example, typically the questions are in this style. Find the stationary points on our function fx to x to the power of 3 minus 3x squared minus 12x plus 7 and determine their nature. So there's two steps here. You've got to find the stationary points from f-x. So we've got to differentiate this once, find out what our x values could be, and then find our y values. Therefore, we've got our stationary points. Because they'll equal 0, we can make f-x equal 0. Determine their nature, we'll have to differentiate it again, and from there we can plug in those x values into it, and it will spit out a number, and if that number is positive or 0 or like negative, then we can know what their nature will be like. We can tell if they're going to be a maximum, minimum, or just a stationary point of inflection. So let's have a go. So our first step is to find the stationary point. To do that, we've got to differentiate our function once. So f dash x is going to be 6x minus 6x minus 12. Did I do that right? No, I missed a 2. Yeah, so 3 comes down, so that's 6. Yes, that should be right. Okay, so we've got this. Now we know to find this, our stationary points, this must equal 0. So let's write that in. Therefore, 6x squared minus 6x minus 12 equal to 0. I'm just going to divide everything by 6 real quick. So it's going to be x squared minus x minus 2 equals 0. If I'm thinking about it, two numbers that times to give negative 2, that plus to give this, that's going to be x plus 1 and x negative 2. X times x squared, yep, that works. And therefore, to make this equal true, x must equal negative 1 and positive 2. So we have our x values. Let's bang them right back into our original function to find our y values, and then we'll have our points. So let's go with our first one, x equals negative 1. Okay, just to make sure we know what we're doing. Our y, I'm going to write that in. Negative 1 cubed minus 3 negative 1 squared minus 12 negative 1 plus 7. Okay, that's going to give negative 1 times 2, which is negative 2. That's going to give positive 1 times negative 3, which is still negative 3. Negative 1 times negative 12 is positive 12 plus 7. That's negative 5. That's going to make that 2, so plus that makes it 14. Okay, so one of the points is negative 1. 14 is one stationary point. We'll say our x equals, where were we? 2. So let's test that. 2 cubed minus 3, 2 squared minus 12 times 2 plus 7. Okay, that's going to be 8. 8 times 2 is 16. That's going to be 4. 4 times that is negative 12. Negative 12 times 2 is negative 24 plus 7. Okay, so 16, I'm just going to grab a calculator for this. Just don't want to make a mistake. 16 minus 12. Whoa, it'd be good if I was actually on there. Sorry about that, guys. Minus 24 plus 7 is going to give negative 13. Yeah, that's correct. So our other stationary point is 2, negative 13. Okay, so we've done, just so you can see, we've done our first step, is that we have found the stationary point from f-x equaling 0. Okay, so we've done our first thing. So tick. Can I squeeze this in here? I'm going to say yes. Okay, now we're going to do step 2, which is determine their nature from f-x. Okay, we ought to do that. If this is f-x, f-x is going to be 12x minus 6. Okay, then we can simply put in our stationary points, the x values of that, sorry, which is negative 1 and 2. So let's do where x equals negative 1 first. So that's going to be f dash dash negative 1, 12 times negative 1 minus 6, that's negative 12, negative 18. Okay, well that means that is less than 0. Okay, so it's going to be concave up. Now, if we do our next one, x equals 2, that would be f dash dash 2, 12, 2 minus 6. It's going to be 24 minus 6, it's 18. Well, that is greater than 0. Okay, so it's concave down. Wait, no, I've mixed it up here. This is concave down. This is concave up. Sorry about that. Yes, this is minus and this is positive. Oof, I don't know where I slipped up there. So that means this, if that's concave down, then that should be a maximum. Okay, so it's going all the way up and it's concave down. That point there, this will be a max. This, if it's concave up, and it's a minimum turning point, will be a minimum. Okay, so we've solved it. Sorry about the confusion, guys. I mixed it up there. I was looking at the wrong thing.